Good afternoon, class. What we'll be talking about today is the converse of the Pythagorean theorem. We are able to use the Pythagorean theorem to determine if a triangle is a right triangle, acute, or an obtuse triangle. There's three theorems today about that. The first one, the converse of the Pythagorean theorem. It's actually a theorem. It says if the square of the length of the longest side of a triangle is equal to the sum of the square of the lengths of the legs of the other two sides, then the triangle is a right triangle. Whew. Basically, if I plug the three sides of the triangle into a Pythagorean theorem, C being the largest side, and it works, then it is a right triangle. So if I had a shape like this, and I plug those three numbers into the Pythagorean theorem, 16 squared equals 15 squared plus 8 squared. 16 squared is 256, 15 squared is 225, and 8 squared is 64. I add the two on the right together, I get 289 equals 256. This is not true. So this is not a right triangle. That's what you're going to use this for. Is it a right triangle? Well, does it satisfy Pythagorean's theorem? Is it? If it does, right triangle. If it doesn't, not right triangle. Let's look at a few examples. These lengths of a side, each three sets, 5, 6, 7, 10, 11, 12, 5, 10, 15, represent a triangle. Can each of these triangles be a right triangle? Well, what I'm going to do is I'm going to plug each one into the Pythagorean theorem. Alright, now look at what I have here. Of all these, I don't know which ones will be right triangles and which ones won't be. But I do know that if I solve each of these, if they equal, right triangle. If they don't, not right triangle. Another thing to look at, each number here is always the largest of the three numbers. Each number here is always the largest of the three numbers. If that's not true, you're not doing this theorem right. C always is the largest number. Period. Alright, 5 squared is 25, 6 squared is 36, 7 squared is 49. 61, does that equal 49? Definitely not. Not a right triangle. 100 plus 121, does that equal 144? Not even close. Not a right triangle. 25 plus 100, does that equal 400? Not even close. Not a right triangle. A lot of these aren't working. Well, let's try the next one. 16 squared is 256 plus 144. Does that equal 400? 400 does equal 400. Finally, we have one. It's a right triangle. 9 squared is 81. 121 and 225. Add those two together, I get 202. Does not equal 225. So again, not a right triangle. The only time this will be a right triangle is if I get the two numbers to match. So if I ever ask you to determine if something's a right triangle, plug into Pythagorean's theorem. Works, right triangle. Doesn't work, not right triangle. Example 2. Again, I say determine if the triangle is a right triangle. So I right away look, which sides are the longest? That's where I'm going to put the C. That's where I'm going to do C squared. Which sides are not the longest? That's where I'm going to just use A and B. So I look, are these all drawn to scale? No, not necessarily. But this one's easy to tell. 16 is the longest side. 16 squared. Does that equal 8 squared plus 12 squared? 256, does that equal 64 plus 144? 256, does that equal 208? No, not a right triangle. Try the next one. 2 square root of 2 squared. Does that equal 2 squared plus 2 squared? Well, 2 square root of 2, that's 4 times 2 equals 4 plus 4. This will be a right triangle. 8 equals 8. This one here, 4 squared, I'm guessing it's the longest. If you're not sure, plug 2 square root of 3 in your calculator. You should realize it's smaller than 4. Does that equal 2 squared plus 2 square root of 3? Quantity squared. 16, does that equal 4 plus, well this is 4, 2 squared, times the square root of 3 squared is going to be 3. So 4 plus 12, 16. Does 16 equal 16? Definitely. Right triangle. Try the last one on your own, but if I did it correctly, I think it's yes, it is a right triangle. The last one is here. Again, I plugged into the Pythagorean Theorem. 25.5 squared. Does that equal 22.5 squared plus 12 squared? Well, 25.5 squared is 650.25. Does that still equal 22.5 squared, which is 506.25 plus 144? Well, when I add the two together on the right side, I find it's 650.25. And that definitely does equal 650.25. This one is a right triangle. So, when we're trying to determine if it's a right triangle, remember, plug it in Pythagorean's theorem. If they're actually equal, it's a right triangle. If they're not, it's not a right triangle. What we end up finding is that if they're not equal, c squared was sometimes less or greater than a squared plus b squared. Our first theorem actually comes about because we found out what it means if c squared is less than a squared plus b squared, and what it means if c squared is greater than a squared plus b squared. Well, let's just think of it this way. If I would draw an equilateral triangle, let's do 7. 7, 7, and 7. Now, the longest side here is, well, it's my choice. 7 is C. And A is 7. And B is 7. I'm wondering what this will be. Well, 49 compared to 49 plus 49. 49 relates how to 98? Well, it's less than. Which means, what happens if c squared is less than a squared plus b squared? Well, I could tell you with 100% certainty that this has to be an acute triangle. It's definitely not a right triangle because it failed Pythagorean's theorem, but because c squared is less than a squared plus b squared, it has to be acute. Consequently, if I would try something that's obviously obtuse, something like this, where it's 12, 9, and 4. It's going to be obtuse. The biggest number is 12. 12 squared is what to 9 squared plus 4 squared? Well, that's 144 and 81 and 16. I end up getting 97, 144. And 144 ended up being greater than. C squared is greater than. This is an obtuse triangle. So, if c squared is greater, c squared is bigger, it has a bigger angle. Obtuse. If c squared is smaller, it has a smaller angle. Acute. From here on out, it might be best for you to use c squared equals a squared plus b squared, just so that way you don't get the greater than or less than sign mixed up. Use c squared first. C squared is smaller, smaller angle. C squared is bigger, bigger angle. If c squared is the same, right angle. Because it's right. So, theorem 7.3, c squared less than, acute. Theorem 7.4, c squared bigger than, it's obtuse. So basically, now I could give you 3 side lengths and say, hey, is this a right, obtuse, or an acute triangle? And you should be able to answer it like that. You should also be able to tell me if it's an equilateral just by if they're all the same. side. So, determine if the segment lengths form a triangle. Wait, form a triangle? So first of all, I have to determine if these are actually triangles. For part one, it asks us to determine if it's a triangle. Well, if it's a triangle, that means the two smaller sides have to be added up to a larger number than the largest side. So 5 plus 6 is greater than 7. Yes, it's a triangle. Check. 10 plus 11, is that greater than 12? Check, it's a triangle. 5 plus 10, is that greater than 15? It is not. Not a triangle. It's not even a triangle. Don't put it in Pythagorean theorem. Don't put it, square it. It's not even a triangle. Don't even worry about it. It's not going to be acute, obtuse, or right. 12 plus 16, is that greater than 20? It is. It's a triangle. 9 plus 11, is that greater than 15? It is. It's a triangle. So, 4 of the 5 were triangles. 3 isn't. I don't have to go any further with number 3. But the rest I actually have to square and determine what the sign is for C. Is it greater than, less than, or equal? If it's greater than here, it's going to end up being obtuse. If it's less than, acute. If it's equal, it's right. So, 49 blanks 25 plus 36. Well, this ends up being 61. This is 49. The alligator always eats to the larger number, so it should be a less than sign. So this is a triangle, but it's also an acute. See, it's less than. Acute triangle. Yes, it's acute triangle. 12 squared, 144. What's its sign? I don't know yet. 100 plus 121. This ends up being 221, 144. Yeah, this is definitely less than. We have 2 acute triangles. Because C squared is less than. Over here, 20 squared is 400. 16 squared is 256. 12 squared is 144. Well, that's 400 and 400. They're equal, which means it's a right triangle. And the last one, 225. I don't know the sign yet. 81 plus 121. 225, the sign, 202. It has to be a greater than sign. Greater than is obtuse. C squared is bigger. It's a bigger angle. So, if it's obtuse, C squared is bigger. Smaller, sorry, if it's acute, C squared is smaller. If they're the same, C squared and A squared plus B squared, it's a right triangle. Here's your examples. The next question, what if we gave you a real life example? To determine if a wall is perpendicular to the ground, you measure the height of the wall to be 8 feet. So let's start drawing ourselves a picture. We have a wall here. Here's my wall. It's inside of a building. I know, it's artistic. I should be an artist instead. Moving on. The height, 8 feet. Awesome. Now, I measure 7 feet along the ground. I go from here to here, 7 feet. I want to know what the length of the string from the ceiling to the base have to be in order for the wall to be perpendicular to the ground. What would this have to be from ceiling to base? What would that length have to be for this to be perpendicular? Perpendicular is a right angle. So what would it have to be for a right angle? Well, let's draw this a little bit separate from here. I have x here. I want a right angle here. This is 8. This is 7. Oh, let's just solve for the hypotenuse of a right triangle. X has to be what number? Well, it has to fit in Pythagorean theorem. 8. Let's again keep it where c squared comes first. C squared equals a squared plus b squared. X squared equals 64. 7 squared is 49. X squared equals 123. So x is going to be real close to 11. But I'm going to need a calculator here. 120, 123 to the 0.5. 11.09. Did I give units? Feet. My measurement would have to be real close to 11.09 feet. So essentially 11 feet 1 inch, roughly. If it's exactly that, I've got a perpendicular wall. It's straight up and down. If I don't, I have an obtuse or an acute angle depending on the size. So x here would have to be 11.09. Awesome. At this point, you should know how to be able to tell if a triangle is a right triangle, obtuse, or acute. And you should also be able to plug it in and figure it out. Remember, c squared smaller, smaller angle. C squared greater, greater angle. C squared the same, it's finally right. Alright, so c squared less than acute. C squared greater than obtuse. C squared equal right. If you know that, you're going to be doing real well in this section. That's all I have for you today. Till next time.